So, what's that?
Go for it.
All right. So I'm Jeff Adams with the Georgia Air National Guard. I was just recently promoted to Senior Master Sergeant. Yay! That's some cool stuff. I'm excited about the new position. I'm now a superintendent over the transmission shop, so I'm excited about that. Really group of great guys there. But I'm also, on my civilian job, I also work at CSX as a security architect. And I've been at CSX now for, I guess I've been supporting them about 18 years. I transitioned from a contractor to a CSX employee about 3 years ago. But I'm in their security operations department, and I primarily have, over the years, have been managing DOP solutions. I've been managing proxy solutions, done some of the firewall work, and so forth. Just a wide variety of different things. The one thing that I'd kind of point out for anybody that's wanting to get into any type of technology job, there will always be a security aspect to it. And security is going to be the way to go if you want to keep in with some type of job security, not to put any pun into it. But anyway, I've got a couple of different, I guess, 2 or 3 pages here of notes that I kind of threw together, and I'm just going to kind of go from top down. I'm kind of starting off with some different security, enterprise and security type tools that we use. I know this session was called Security Troubleshooting Tools, but I want to actually talk about some of the different tools that you actually would implement into a enterprise environment, and what are they used for. And then as we kind of go through this, I'll actually go into a little bit more real basic stuff, understanding network terminologies and stuff, and then provide some basic command line information, and then we'll kind of, I've got a bunch of really cool websites at the end that I'd like to share with you. But anyway, traditionally, you've always started with firewalls. You've always wanted to segment off your network. The problem with most environments today, and I'm sure the government and the military is not like this, but the problem with most environments today, business environments, is it's flat, meaning that all your clients, all your endpoint clients, along with all your servers, are typically on the same network. They may be segmented off via maybe VLANs or things like that, but they're still on the same flat network, which is bad, because you don't want any chance of a user or an insider threat or an outsider threat getting into your corporate network and then being able to pivot over to a server, especially if it's talking about your OT, your operational technology, your ICS or SCADA systems. And from a CSX perspective, then that's all of our transportation, our transportation type systems that move the trains. So it's very important to keep a lot of that stuff separate, segmented the best you can to make sure that there is no cross-contamination from your corporate network to your OT network. And so I know Robbie was talking about this a little bit earlier, and it's good to hear other people talk about it. Zero trust. Now, I think she was kind of going down a different little path, but what zero trust means to us is all of our end users, instead of actually segmenting the corporate network, which is where a lot of the users are today, just putting them directly onto the internet. Don't even have them come up on the corporate network. And then at that point, just have them VPN or there's new solutions coming out that basically is always on, but you're authenticated based on certain credentials, whether it's a machine certificate or maybe a multi-factor authentication. And in CSX's case, we use Okta for the multi-factor authentication. But even like for us, for the Guard, we've got the CAT card, the smart card, and your PIN number. So we've always been doing multi-factor authentication for years now. But from a firewall's perspective, you should be, really segmenting your networks. IDSs, intrusion detection, intrusion prevention systems. Basically, that's to help also segment your networks in a fashion where you may have some segmentation, but you may also have some allowed rules allowing traffic from one network to another network, and you want to put some an intrusion detection and intrusion prevention systems in that path to help monitor for any ill will type traffic or any type of vulnerability traffic that may impact your systems. And then you have proxies. I know at CSX, well, we've had an on-prem internet proxy for as long as I've been there. And the solution that we were using was called Blue Coat. And it's basically what the proxy does is let's say you're the user on the network and you want to go to Google. Well, you're basically saying, hey, I want to go to Google. The proxy says, okay, you want to go to Google. So then the proxy actually goes out to the internet on your behalf and grabs that Google page and then brings it down to you. So it's basically from if you're thinking of from a security perspective, the proxy acts as a man in the middle. So you wanted to go somewhere, so he says, okay, I'm going to go get it for you. One of the cool things that critical things that CSX started doing, I guess about 10 years ago, was doing SSL interception at the proxy, because it's been very critical, especially here late, where you want to go to a secure website, so you want to make sure that it's HTTPS and that it's a secure website that you're going to. The problem is that the bad guys are actually doing the same thing. What they'll do is they'll stand up a server or something over the weekend and go ahead and get the credentials and get the certificates and all that set up, and then do a let's say either, I'm going to kind of throw some stuff out there, but like DNS poisoning, where you may be thinking that you're going to one website and the DNS poisoning is actually pointing you to a different website, which is actually now the hosted hacker website. So it's very important to actually start doing SSL interception. But of course, when it comes to financials, HIPAA, things like that, we definitely got to make sure that we're not intercepting that traffic, because it becomes an issue as far as that type of data.
Hey Jeff, how are you all handling the DNS over HTTPS?
We've had a couple of different conversations over that, and it hasn't really gone very far, because I actually had the manager in our Security Operations Center inquire about it, and we did some initial review, because we are no longer using the on-prem proxies. We've started using a cloud proxy called Zscaler, and so I don't know. I don't know the answer to that. I'm not privy enough, or I'm not knowledgeable enough to answer it. All I know is that it's there. I don't understand the full understanding how it works, because I know it basically tunnels through 443 for DNS traffic. But I don't know, like today, since we're going through Zscaler, I don't know if Zscaler actually adheres to that. So that would be something I would have to go back and kind of take another look at to see how Zscaler, our cloud proxy, actually handles that.
Yeah. So so it tunnels through HTTPS, but it looks like HTTPS traffic, so you can't just block all 443 traffic. What some people have done is just block the DNS servers directly that support HTTPS, so you can't actually get to them.
Right.
There was a some GitHub link that I found that has a list of, I don't know, it must have been like 50 to 100 different HTTPS servers that you could block to keep it from happening. Right.
Cool. So from a proxy's perspective, from a CSX perspective, we now use Zscaler. The nice thing about Zscaler is it's cloud-based, so it doesn't matter where you're at. Now, I guess to some extent, CSX has been doing their own cloud proxy for years. I implemented we took the internal blue coats and we ordered some low-end blue coats and put them in the DMZ, and basically had the internal DNS name, which is called webproxy.csx.com, and basically published that on the internet as well. So we are explicit proxy, so the browsers would have through a GPO saying you are going to go to webproxy.csx.com for any internet access. So if a CSX user took their CSX laptop and went to Starbucks, then they would still hit webproxy.csec.com and just hit the external-facing blue coat and still be proxied that way with transparent authentication. But anyway, now that we're at Zscaler, everybody, whether you're on-prem or off-prem, you're still going through Zscaler at that point. And we've been in this particular environment now for 6 months, I guess, and it's been very good. We've really enjoyed the transition. It's been very a good experience. The next step that we want to take, and it kind of boils down, it kind of falls in line with the Zero Trust, is Zscaler has what's called a ZPA. It's a Zscaler Private Access. And what it does is if you're trying to access internal resources to CSX, then we would turn on the ZPA functionality of the client that's on your laptop. And then through Zscaler, you're being then kind of like a reverse proxy going back into the environment. But the nice thing is as soon as you log on to your CSX asset, your laptop, with your CSX credentials, the tunnel is automatically created back through Zscaler back to CSX. So it's an always on, but you have to authenticate. Your machine has to authenticate. The user has to authenticate to make sure that you're approved for the resources that you're going to be accessing on the network. Share content. Okay. So Jesse, you see that whatever Aaron
Yeah, it says start annotating. Yeah.
Okay.
Yeah, I see that.
All right. I've never used that before, so I wasn't sure.
Oh, you're good.
All right. Okay. Well, I'm going to stop annotating because there you go.
It actually might be easier to highlight in using Word.
I got you. But anyway, email hygiene. We have traditionally been using Cisco Ironport. We have just recently migrated over to Proofpoint. So Ironport was an on-prem email hygiene solution, which dealt with anything with spam, malware, and the like. And basically, one of the first steps that it would do is as an inbound email would come in, first thing is, okay, the recipient, we would bounce that against Active Directory. Did it exist? No. Then we just wouldn't process the email. When we first started using email hygiene solutions some years ago, it was so amazing because we were blocking, literally, we were blocking over about 7 to 8 million messages a week, compared to the 200,000 or 300,000 that were legitimate emails per week. And watching the statistics, watching the patterns over the years, we are now blocking maybe 300,000 or 400,000 a week. So the amount of traffic has decreased, but the craft of the email has definitely increased. You can definitely see an increase as far as how the bad email is being crafted these days. They're really trying to get through, because the weakest point in any security, especially when it comes to email, is going to be the user. So it's regular training, regular awareness as far as the user's understanding. You just don't go in there and click on something. And even today, we still have people, CSX, still click on stuff. But with the new cloud solution that we now have called Proofpoint, so all of our inbound and outbound email, even though we are migrating to Office 365 Exchange Online, we still have all of our email still being filtered through Proofpoint, which is the new cloud email hygiene cloud solution that we currently have today. And go ahead.
Hey Jeff, did you read the talk about spam? Did you read the book Spam Nation by Krebs?
No, I have not.
If you have not, it's a great book that talks about the spam coming out of Russia.
Okay, and that was Krebs.
Yeah, I think Brian Krebs.
Okay. Cool.
But it's called Spam Nation. And for those also listening, if you want a really crazy read on the spam and how that all got blocked and what happened in Russia, because they were sending tons of spam. I mean, spending $100,000, of overhead in a year but causing cybersecurity to expand several $1 million. It was it's a crazy read. You want to know more about it?
All right. Well, thank you. But yeah, Russia. Just watching our logs, Russia is definitely the top one that usually we receive a lot of either connections, email, and such from. And just to kind of highlight, CSX is a major transportation system, critical in the United States. So we are always a target. And speaking of target, this was when we were doing a proof of concept with Proofpoint. We stood up the connectors with our email, with the Exchange on-prem and Ironport, and we started monitoring the email through Proofpoint for about 30 days, and some of the things that they found was amazing. But this one particular example, this goes to show you got to be careful as far as what you put out on the internet. In this particular case, we found a lady, or Proofpoint found a lady in our email threads that out in California had stood up a LinkedIn account claiming that she was the CSX CEO. And because of that profile in LinkedIn, the bad guys started sending CSX email to her, thinking that she was actually the CSX CEO. So because when we started receiving these emails for her, we were like, well, who is she? We don't even know who this person is. When Proofpoint started doing the investigation, it found out that it's just some lady that stood up a LinkedIn account out in California that's claiming to be CSX CEO. So and again, Proofpoint also proved that they were able to identify that in their tooling and was able to prevent those emails from coming in. And so the other caveat to that is making sure that the headers, because the way Proofpoint, one of the things that they're looking at is are the specific headers as far as where they're coming from and where they're going to and so forth. But anyway. Email hygiene is very important, especially when users are usually your weakest link to begin with. So endpoint, there's I think Robbie kind of touched on this. There are tons. I think she kind of mentioned Tenium earlier. There are just tons of different endpoint solutions. We at CSX we currently use Crowdstrike, and previously to that we were using semantic endpoint protection. We are preparing to start doing a proof of concept with InGame, which InGame was bought out by Elastic. So I don't think Elastic calls it InGame. I think they just call it endpoint something or other. I don't remember now. But
they're still calling it InGame. I'm actually using it in the cloud and as part of my Elastic suite. It's really nice.
Oh, sweet. And this is Robbie?
Yeah, sorry.
Okay. All right. No. Thank you, Robbie. Yeah, because we just stood up our management console this week, and so I've got an onboarding meeting with them next week to start standing up some endpoint POCs and start testing and playing around with that. I mean, we signed a 3-year contract with Crowdstrike, but we're halfway into that, so we definitely need to start thinking about what we're going to do over the next 9 months or so. But one of the biggest things that we're trying to understand, not just like malware, but threat, insider threat, the behavior analytics, but also because like Crowdstrike, the way Crowdstrike works is it doesn't use signatures. It uses behaviors as far as how something might be running. Like we found out early on that we had to actually put it in some exceptions for PowerShell because right out of the box it wants to block any PowerShell scripting. But CSXs, especially in their server environments, actually use a lot of PowerShell scripts, especially when it comes around to Microsoft's Azure, Office 365, and such things like that. So we're trying to be, selective, but we're also trying to make sure that we broaden our protection as best we can without causing an impact. Because it's the challenge that our security department has is CSX is about availability. So we are constantly advocating for the security side of it to make sure that CSX is protected. but their primary concern is availability, making sure that everything runs and it runs all the time, with it being a transportation company. Matter of fact, just to kind of give you an example, the last 3 months of the year, which is what CSX calls, it escapes me now, but they don't want any changes done to the environment the last 3 months of the year, because that's when most of their shipments are done, whether it's intermodal, whether it's train, truck, whatever it might be. The last 3 months, unless it's critical, they don't want any changes done. All right, so endpoint data loss. So data loss, I've been managing that through what was originally called ForcePoint. Well, actually, it was WebSense before ForcePoint, then at ForcePoint, and then I can't remember who took it over after that, but somebody else has taken it over. But because of us trying to do cost cuts, what we've done is we've dissipated the ForcePoint DOP solution and kind of migrated the DOP functionality into the individual solutions. Like Proofpoint has its own DOP functionality, so we've been standing up all the DOP policies there. Office 355 has DOP policies. The Zscaler has DOP policies. So instead of having even though from my personal experience, it was better to have a single DOP solution and monitor all your data at rest and data in motion, and have a single pane of glass for all your DOP stuff. It was easier to manage that way. Unfortunately, to cut costs, even though the FTE or the full-time equivalent time is probably going to go up a little bit, because now you got to support DOP policies which are different across all the different other solutions. But some of the things that that from a CSX perspective, I mean, we don't really have too much to really worry about, because we don't worry about PCI. The only stuff that we have to worry about are really employees and their dependent Social Security numbers and corporate credit card numbers. So we monitor for that, but and since most password encrypted files, you can't, most DOP solutions can't scan those, so we block that. Plus, we also got a little creative a few years ago. We were concerned about certain maybe executive documents getting compromised or getting somewhere where they shouldn't go. So we created what we called either a watermark or a hashtag, and took all the templates that the executive or the C-suite would use, and tagged in the metadata this particular hashtag or this watermark embedded into those documents. So in the event, it's not like we would block it, but we can at least audit that traffic. So if all of a sudden some certain documents like financials actually went outside the CSX environment, they would get audited. So we would be aware of that traffic. And containerization. So I think Robbie kind of touched on this too, Kubernetes and a few other things, but it just understanding what containerization is and understanding what that means. And I'm going to keep it real high level because I'm still kind of learning this piece of it myself. But it's basically, let's say you've got this particular service that may only need to run at a certain amount of time for a certain period or a certain thing. All right. Well, no reason to have a whole computer server or anything just for that one service. So what it does is that you have a host with all these different containers or these images, and as that service is required, it'll get spun up, it'll do its thing, and then come right back down. It'll just shut itself down. So it's these little tiny service images is what they are. And the bad thing with those is if there's a compromise or a vulnerability within inside that, and then it gets, comes up, does its thing, maybe it's a bad thing, and then it shuts itself down. Well, everything associated with that event is now gone. So if you're dealing with containerization, it's really important to make sure that you're logging that activity. And from my personal experience, I'm still learning that aspect of it, is understanding the type of logging that we can actually pull from those containers and those images to make sure that we're capturing the activity, because it could be a good thing for troubleshooting. Like all of a sudden you've got something that's not working right. Well, then the developers can actually look at the logs and kind of determine, well, is this a malicious activity or was there just bad coding or something?
One thing on that, Jeff, is that people can go to I know AWS Lambda Functions or Google Cloud's Cloud Functions, something really silly. You can play with. They're kind of like Docker containers. You just put a function up that it runs, does one little thing, and you can do a lot of different actions with them. And they're supposed to make it more secure because it's not, you don't have a server running 10 things, but they have their own problems. And there have been vulnerabilities where you can break out of a Docker container to get to the host.
Yeah. And those that are on the call that maybe that might have an interest, you can go to the Docker website and download the Docker desktop for free and play with it. I've done it. I've been trying to get familiar with it myself, so I've downloaded it. I spent several hours just trying to understand it because I've been doing it from a command line, and I guess there's another tooling, some kind of UI that you can do it. I forget the name of the UI. But I've been trying to learn it from a command line. I've been trying to get more command line centric for myself. It just seems like you could do a lot more from that perspective, especially if you want to start scripting and automating things.
So some of the capture the flag events, some of those challenges are actually you're connected to a service that spawns a Docker container, basically. So you have your own environment to do whatever you're going to do, so you don't mess with other people. I've seen some of the capture the flag events. So,
Sweet.
Yep.
Mm-hmm. Now, I'm only going to kind of touch on this. I think Robbie did a really great job kind of touching on the different cloud service models. But just real high level again, you got these are the three basic ones. So you got the infrastructure, which can deal with like VM, storage, load balancers, and such. You got the platform, which may encompass like databases, web servers, and such. And then the software, which is email and any other type of software that you may be hosting up in the cloud. And I'm still learning the cloud side of it, so I just wanted to kind of lay out the three primary pieces there. And so I guess some of the directions that CSX is going that we're looking at, we're doing some POCs with AWS, we're doing some stuff with Azure, and then there's just tons out there, and where this kind of goes from cloud services into the next bullet item is CASB. So I've done some research in CASB just to understand what it does, what it's for, and it's going to be huge because if corporations, companies, and DoD and the like are moving a lot of their service or a lot of their work, network work up to the cloud, and all of a sudden you got all these different cloud services. What about the lateral movement? And some if you're in a certain conversation, you might hear people talk, well, what about the north and south traffic? What about the east and west traffic? Well, basically, if you're going from, and this is the way I interpret it, is if you're going from on-prem up to the cloud, that's south to north traffic, all right? But if you're going from cloud to cloud, you're going east-west, southwest, or east-west, west-east type traffic. So once you start moving to the cloud and you've got all these different cloud services, and what if those cloud services are talking across from each other and they're never coming on-prem? Well, you just lost that visibility. Now, you may see some visibility within inside each of those cloud services, but what a CASB does, the Cloud Access Security Broker, is once you set up a cloud or a CASB, then you can actually put these hooks into all your different cloud services and apply policy to it. So if all of a sudden you've got, let's say, some payroll cloud service, and then you've got some other cloud service, and you want to make sure that you have nothing leaking or accidentally moving from your payroll service, cloud service, to another service that has nothing to do with payroll. So very important. And so I'm still kind of, me personally, I'm still kind of battling that. CSX today doesn't see the value in that just yet, primarily because we haven't moved too much into the cloud yet. Though we are moving in that direction. When I talk about the CASB at work, I try and make sure that they fully understand that, if we don't put it in at some point in time, we're going to lose that visibility. All right, so that kind of takes care of that first section there. The next section is going to be just real basic stuff, but it's important things. So I'm going to kind of highlight some of this, the OSI layers. I know at the guard unit, anybody, I know in the last department that I was in, I was always harping on the OSI layers, making sure people at least understood what it meant. And so now being a superintendent with the transmission team, again, I'm going to be kind of harping on that because I think this is very important, especially from a troubleshooting perspective. Even though the last department, we were probably dealing with anything from layers, 1, 2, 3, maybe 4, but the transmission team may only be dealing with layers 1, 2, and 3. And what that means is, if you're looking at this, is as, let's say you've got a packet that leaves your machine, whether it's a satellite system, whether it's a computer, whatever the case may be, you've got a physical connection there. So it basically leaves out that connection and then goes up the stack. And then when it reaches the destination, it basically goes back through the physical connection and works back up the stack. Or I guess I said that a little wrong, but as it goes down the stack and then out the wire and then back into the end device and then back up the stack, and then it stops wherever it needs to stop at. So for example, if you're troubleshooting a connectivity issue, the first thing that you should be checking is your physical connection. Is it plugged in correctly? Is it plugged in all the way? We were called, or I was called at 2 a.m. one night because the guest wireless network was down. I'm like, why are you calling me at 2 a.m. because the guest wireless network is down? Well, unfortunately, we had a remote site that I didn't know of. We had a remote site that was their only network connectivity was through the guest wireless network, through the wireless access point there. And they were trying to get some work done. It's like, you gotta be kidding me. This is crazy. Why is that? But anyway, we just so happened to have one of the on-call guys at the data center that night, and he said, well, why don't I go check the plug? I said, why? I mean, nothing changed. I mean, why would you? But anyway, he went ahead and checked it anyway, and sure enough, it was lodged. It was lodged out enough to where it wasn't clipped in, and which is crazy because I haven't touched it because I was the one that was managing it. I haven't touched it in probably 12 to 18 months. So it's very important to always go to the easiest thing, which is the physical activity of it, and just make sure it's plugged in. And it's kind of important to understand what the different layers really respond to. So we kind of talked about the physical layer as far as the physical connectivity, but like the data link layer talks about like switches and the ARPs, the frame relays. The network layer is really to do with IP addresses. So you're dealing with routers and the layer 3 switches. And it's kind of important to understand what the difference is between a switch versus a layer 3 switch. So if you're not familiar with that, you might want to read up on that. Layer 4, and I'm not going to go any above layer 4. If you want to read more above layer 4, please do. But me personally, I usually don't go any further than layer 4 with my troubleshooting from a security perspective, unless I need to, depending on the tooling that I'm dealing with at that time. But it's interesting, most of the troubleshooting that we do is usually with the network folks, and they're always claiming that the firewall is blocking something and kind of find out that it might be a misroute or something. But transport for the layer 4, so it says here TCP UDP, but in a logical sense, if you're layer 4, if you want to associate layer 4 with like firewalls because of the ports that you're actually, even though it's a source and destination IP address, but it's also source and destination port as well, if you want to make that association. But if, of course, you do have the other 3 layers with session, presentation, and the application layer. Some real basic stuff. So TCP UDP ports, there are 65,535 ports. The first 0 through 1,023 are your well-known ports. And it's always a good idea to understand some of your other common ports like port 80, 443, 22, 23, 25, 123, 3389 versus 389. And so you can easily do a Google search on that. I guess that's something different on that. But you can easily do a Google search for your ports. If you just don't know what a port number is, just do a Google search for it. You'll find it. But it's if you're having problems with a website and understanding whether it's HTTP or HTTPS, because HTTP is port 80, HTTPS is 443. And like Jesse was just talking about using DNS traffic. DNS, which is port 53, being tunneled through port 443. And so that's very interesting on how that might work. Just like bad guys might try and tunnel malicious activity through DNS traffic. So they're trying to send a payload over 53, just knowing because most corporate networks will allow port 53 through their firewalls. So where the bad guys might try and tunnel a payload into that packet. All right, so I kind of threw this in here because it was just kind of interesting. I was somewhere one time and I was having some network issues, and so I thought I'd bring up the Windows command line just to do some real basic ping and trace route, and so some basic network troubleshooting, and it was blocked. I was not allowed to open the command prompt, I guess based on a group policy, and I thought that was kind of odd because it's just a command line. But I pulled a PowerShell and I was able to get PowerShell without a problem. And I don't know if most people here understand, but PowerShell is very powerful. If anything, PowerShell should have been blocked and not the Windows command line. But let me kind of show you real quick. So if I bring up like a command line here, so if I do, let's say dir, I don't know how many people here on the call would really know command line, normal command line, but you do a dir, and it shows you the directory and the contents of that directory. If you do an ls, of course, it doesn't know what ls, but if you're a Linux guy, then you know what ls is. Ls would basically do the exact same thing what dir does. And if I do an up arrow, it does give me. All right, so that's cool. But if I close it and then reopen it and then do an up arrow, it doesn't give me my last commands. But if I go ahead and pull up PowerShell, now this is still a Windows environment. I do PowerShell here. If I do dir, of course it'll give me the list. I do an ls, it also gives me the list. And if I close PowerShell and then reopen it, and then up arrow, it still has my history. I don't know if there's history here. Yeah, but in Linux it does. So the cool thing about PowerShell is let's say you do Windows stuff, you do Linux stuff. Well, in PowerShell, it doesn't matter what command that you're using, whether you're more centric to Linux or Windows side. In PowerShell, pretty much all the commands will work the same, which is kind of nice because if you all of a sudden you're a Linux guy, you're finding yourself doing more and more work in Windows. Well, all those Linux commands will still work though you're in Windows. And then PowerShell scripts are huge. And complementing those PowerShell scripts with other tools such as maybe Phantom or some other automation or type tools, you can just it's just endless of what you can with the possibilities. That's why, from a Crowdstrike's perspective at CSX, we want to block PowerShell because it is so powerful that it can what you can do with it. Okay, DNS. We've kind of touched on DNS a couple of different times with the port and tunneling it through HTTPS. But NS Lookup, it's so interesting. You know, you know, we got a couple of new folks up at CSX, and or you know, I'll have a technology guy, you know, say, hey, you know, I can't get to this website. Well, the very first thing I usually do if the website doesn't work is I'll do an NS lookup on it. So let's say for whatever reason Google would come up. So if I did an NS lookup for google.com, and if it gives me IP addresses, that means that it's accessible, or at least it has the network, because I don't know if most people understand this, but when you go to Google, the network doesn't understand Google. If you don't somehow translate that name to an IP address, it'll never make it there. So that's where DNS is very important, because if it can't be translated to an IP address, you'll never be able to get there. So usually this will be the first thing that I do. If all of a sudden somebody can't get to a certain website, I'll make sure that it translates to an IP address. If it translates to an IP address, great. Also, can I get to it? Can I get to the website? It's amazing. About 20-25% of the time when a user can't get to a website, it's been fat-fingered. It's got a typo of some sort. But it's just being able to understand. Another thing is, for example, if we did the NS lookup here for Google, right? It tells me what DNS server that it's going to. All right, so that's basically just my Linksys router. So my Linksys router is on it on it's basically the non-authoritative. All right, non-authoritative, but basically it goes out to an authoritative DNS server, and if it doesn't already have the response in its cache, then it goes out to an authoritative server to get that response. But let's say at CSX, we have a website that can't resolve to an IP address. Well, you know, for all I know, there might be a problem with our inside DNS servers. All right, so what I can do is go to NS lookup, which if you notice the prompt has changed. All right, so I'm actually inside NS lookup now, and then I can actually say I want to go to a different server. Let's say Quad 9. All right, so now I'm actually pointed to Quad 9 for my DNS resolution. And then, you know, if I do Google again, it should be pretty much close to the same IP addresses, but it's not. It just means that Google has a lot of different data centers. They have a lot of different load balancing. And so, though internally I was hitting 64.233, from a Quad 9's perspective, I was hitting 108.177, which is not a big deal, as long as it's resolving to a Google IP address.
Hey, Jeff, while you're there, you want to try to get all the records when you do an NS lookup?
Yeah, how do you do that?
Should be, it's, what is it, type equals all, or set type equals all?
2 words or 1 word?
A space, and then type equals all, if I remember correctly. And then look up Google again. And so it actually gives you the name server, the mail server. Some other servers will give you like a list of a whole bunch of information, or anything you can get from their domain when you do it that way.
It's a very powerful tool. I mean, you can get a lot of information from NS lookup. Yeah. But in its simplest terms, I mean, you know, when you're trying to troubleshoot, what can't I get to, or even something internal? Well, you're trying to go to an internal website, or you're trying to get to a server, and you're doing it by name, by the fully qualified domain name. Well, if it doesn't resolve to an IP address, you're not going to be able to get there, because that's how networks work, is through MAC addresses on layer 2 to IP addresses on layer 3. And this is where the OSI layers come into play again. You have to understand those OSI layers when you're troubleshooting something. You really got to understand where you're troubleshooting the problem at. Okay, ping. I'm not going to, you know, I think hopefully everybody understands. So obviously I'm still in NS lookup, so I just need to exit out of that. And if I wanted to ping, let's say Google, of course, first thing it does, what's the first thing it does whenever I go to ping Google? Anybody? And it has to resolve it to an IP address. So the first thing it did was resolve it to an IP address, and then it was able to ping it. If it didn't resolve to an IP address, it wouldn't be able to ping it. Okay, trace route. So even though I've got it noted here, ping is based on the ICMP. Trace route does the same thing. But if I did trace route to Google, this basically tells me the path that it's taking. So of course, what was the first thing it did? It resolved it to an IP address. It has to have an IP address. Of course, that was my gateway. This is I've got in my home. I've got a couple of different segments, and then finally, I think this is the actual path out into the internet. Yeah, and so it finally went out to the internet. Now it's hitting the internet IP addresses. So it shows you what path it took inside my house, and we'll kind of talk about it down here, but understanding what the difference is between a private IP address versus a public IP address. And see, some of this is even pretty cool. It even shows you that I'm hitting the west side. I'm hitting the Comcast west side, some kind of router there. Now I'm hitting Marietta. I'm hitting Marietta, Georgia. So whenever you're doing these trace routes, it's pretty cool. And when you're doing it, when you're troubleshooting a network connectivity inside of a business, you're going to see similar things. The biggest caveat though is if you're trying to go through you're trying to do a trace route through a firewall, and the firewall is not allowing the ICMP packets to I think it's the echo and response packets, then what you'll end up seeing is just stars. But if it finally gets through the firewall and gets to the other side, and if those packets are allowed back through, you may see some responses coming back through the firewall. But interesting here. So just from my own experience, that is Google. And it looks like, just reading through this looks like we hit a Google, maybe the Google data center, or whatever data center that they may have in Miami. But it's interesting. I look at all these different hops. You know, the first three are inside my house. Then I leave my house, and I'm on the west side of Jacksonville, and then I'm hitting Marietta, Georgia, and then who knows where these guys are at. And then I finally hit a Google server down in Miami. And it's just amazing of the route that you're taking to get there.
It's even more amazing that you went from Florida to Georgia back to Florida.
Yeah. But you know, the way the ISPs try and do though is the less congested route. So obviously I went north to go back south because it was less congested, or the fastest path, because HSRP or any of those other routing protocols, they optimize, the ISPs, they try and optimize that stuff the best they can, because again, reliability and availability. When people loses their internet connectivity, it's bad. It's amazing how bad it is when people start losing their internet connectivity. So IP config, from a Windows perspective, I know, okay, I've got 14 more minutes left. So IP config, I want to make sure I leave some time for some stuff at the bottom. So IP config, and again, every device that's on your network has to have an IP address. So if you do an IP config from your machine, depending on how many adapters that you have, here's that's VMware, okay, LAN. Okay, so I'm actually on my wireless LAN adapter, and this is the IP address of my laptop, and the subnet mask, and the default gateway. And so the default gateway 12.1. Let's see, let's go look at that. Yep, 12.1. My default gateway was 12.1, so that was the first path, path that I took when I did this trace route to get out to Google. So just, and then if you do ipconfig/all, that actually gives you a lot more information. So from my wireless LAN adapter, now I've got, tells me what network adapter I'm on. I've got, seems to be called the Killer Wireless NAC. And then DHCP enabled, and so we're kind of talking about dynamic. So dynamic host. And then I got a quick question in here. It says, what if your IP address was the 169.254? Anybody? All right, so if your machine was unable to get to your DHCP server, in this case, my DHCP server is my actual gateway and my Linksys router. But if for some reason, if your machine can't access your DHCP server, Windows is automatically going to assign it a 169.254 address. I don't remember what the reasoning behind it is, but I know that this is assigned, and you still can't go anywhere. It's just all of a sudden you've been assigned, Microsoft has assigned you this IP address. So if you ever see that IP address and you're doing an IP config and you're doing troubleshooting, you see a 169.254, you know that you're not getting to the DHCP server to get an IP address. Now, is it a layer 1 issue? Are you physically connected, or is your Wi-Fi adapter turned on? Little things like that. You've got to start with layer 1 and then work your way up.
So Jeff, the Pip addresses were created by Microsoft, so people could just hook their computers into a basic switch, and they could talk to each other.
Ah, gotcha. Well, that makes sense.
And personally, being a network guy, I don't like them. They can cause you to look at different things because you think, oh, I have an IP address. No, it's not the right IP address.
Yeah. So most places are DHCP. Typically, where you'll see a static IP address is usually servers or some kind of service device, something on your network, whether it's corporate, whether it's OT, SCADA, ICS. If it's bound to do a certain type of service and it's not an endpoint, typically you'll have a static IP address and it would be assigned. And so keep that in mind too, because because I've seen some weird stuff where I've seen I saw a developer one time give himself an IP address, and I can only assume, I'm going to speculate, that he was trying to do some testing and he gave himself a static IP address from the DHCP scope and didn't tell anybody, and then it ended up having a conflict and ended up causing a problem on the network. So just be very careful when you're doing that. Most static IP addresses are a controlled item. It's usually controlled by a certain team. At CSX, the static IP addresses are controlled by the network operations team. And so if I want a static IP address, I put in a service request and say, I need an IP address in this VLAN or in this subnet for this purpose. And that IP address's host name is going to be this. This way they can tie it back to the owner and what it belongs to, and so forth and so on. Now, as we were talking about private IP addresses a while ago, from my IP address here, this 192.168.12 113. When it comes to private IP addresses, if you want to, I've got it linked here, but if you just look up RFC 1918, it talks about the private IP addresses. The big thing about these private IP addresses is they are not routable on the internet. So if you all of a sudden try and do a static IP address on a device that you're trying to connect directly to the internet, it's not going to work because none of these IP addresses can be routed on the internet. Basically, that's where you get padded on the internet. So for example, if I go to like I'm on my home network, so if I go to what is my IP, we'll say .com. And so what this does is it tells me what my internet IP address is of my house. So most residential will always have a DHCP type address on the internet. So this will probably eventually change. It depends between ISPs, but this is what the internet sees me as, is this IP address. Now my machine, my laptop here, this is the IP address that it's actually assigned to my laptop. When I go out to the internet, this is what the internet sees me as. All right, so we just talked about the that as well. Netstat. So Netstat is just a cool little tool that if you're trying to figure out what services are running on your machine, and because you never know if you got anything malicious running on your machine. So this will quickly tell you what's. I mean, I've got all sorts of garbage running on my machine, and so yeah, I probably need to clean up a bunch of stuff, but housekeeping. Housekeeping is things that people don't want to do but needs to get done, and that holds true in businesses. For whatever reason, I've recently taken on the responsibility of doing some. I've been calling it technical debt, and so if you've got, it's not the new shiny object anymore, but it's still in the cabinet, it's still plugged into the network, but nobody's using it. That is still a problem. If it's turned on and it's plugged into your network, that's a problem, especially if it's not being used or monitored or anything. Because if something goes wrong, it can be a pivot point for a bad guy. It can cause problems on your network. Who knows what that device might be? If it doesn't need to be on the network, get rid of it, turn it off, get it out of the cabinet. So that's been one of my initiatives the past 6 months. Is I've already offloaded, I don't know, 90 pieces of appliances over the past 9 months, and I've still got a bunch of housekeeping because we've been migrating a bunch of stuff from on-prem to cloud services. So I've been doing a lot of housekeeping, and kind of a security conscious thing is when you are removing some of that technical debt and their appliances, make sure you're setting back default, making sure that you're clearing those hard drives, making sure that you're sanitizing that equipment before you send it out. Because as soon as it leaves that door, you don't know who's going to have possession of it. Now if you got hand receipts and you got signed signatures and stuff, you still don't know. Just for example, Cisco was having a lot of their components made in China, and it's been some time. It's probably been 10, 12, 15 years, but during that time when China was creating these components for Cisco, China was adding extra components to these circuit boards, and Cisco didn't know it. So once it leaves your door, you just don't know. So just be cognizant of that. All right, so I've got 5 minutes left, but anyway, I wanted to kind of talk about some cool stuff here. I use Untangle at home. Untangle. So it's a nice little dashboard. It's free. It's an OSI. You basically download OSI, but you have to have a piece of hardware for it. It basically gives you different components: a web monitor, virus blocker, application control, firewall. You can even do open VPN connections, like I'm doing for a friend of mine. I'm doing some VPN tunnels for him and doing some offsite backups for him. And then always, I know how to subnet, but I'm not going to do it in my head. So subnet calculator is really cool to go to. Free online network tools, centralops.net, something I've been using for years. Virus Total to analyze files and URLs if you just don't know if it's clean or not. Virus Total is always a good place to go. You want to test your antivirus, you go to ICAR, or some people call it ICAR. I call it ICAR. They've got some test files there that you can test your malware stuff with. Security tools, really cool here. They actually have the top 125 network security tools. And then Black Hat, DEFCON, and then if you really feel anxious, you can look at Kali for some vulnerability and pen testing. Very important. Log your stuff. Because if a bad guy gets into your server, one of the first things he's going to do is dump all the logs, all the event logs, everything on that device. So if you're doing remote logging, either to Elk or Splunk or whatever, the syslog server, very important. But anyway, I've got 3 minutes. This actually, I was hoping it would take an hour, but I was worried that it wasn't going to take very long at all. But cool. Did have some interaction. So any questions, comments?
I haven't seen any, Jeff.
Well, I hope this has been informative for anybody that is listening.
If you want, you can if you can drop that into the slides channel, so people that want to download it and take a look at it again.
Okay, I can do that.
And thank you very much for helping us out and giving us some really good information.